Okay. Hello, everyone. In this chapter, we have already covered the state of matter. Okay, we discussed 5 state of matter. Okay. So in this part, we discuss about the properties like why matters are being in solid state, liquid state, and gaseous state. And we already gone through about the evaporation and what are the factors that affect the evaporation, and cooling due to evaporation we have already completed. So in today's lecture, first we are going to discuss about the physical nature of matter. Okay, so physical is nothing but the physical properties of matter. Okay, so physical properties is that aspect of the matter that can be observed or measured. Okay, just do remember what are the physical properties or aspect that can be observed or that can be measured without changing its nature or composition. And very important, okay, without changing its nature and composition, those properties are called as, or those nature of the substance is called as physical nature. It is dependent on the amount of matter present in a system. Whatever the like matter, like container or the system we have, and we are going to measure the properties of the matter, those properties, they depends on the amount of matter present in it. Okay, suppose here we have one container. Okay, and here we have taken 1 liter of water or any substance. Okay, so here we have measured one
Excuse
liter, whatever the volume is occupied by. Yes, beta.
sir, in this device, I'm having a little issue. I'll join from another device. Will you add me?
Yes, beta. Yes, sure. Okay, suppose we are having more matter here. Okay, so that volume is going to increase, right? So that volume is increases, that means that volume of the that matter in that particular container is totally depend on the amount of matter. Is it or not? So whatever the properties, they depends on the amount of matter, are called as physical properties of the matter. Okay, let's discuss more. The physical properties includes appearance. So what are the physical properties? Number one, we have the appearance. Number second, we have the color. Number three, we have odor. Odor means the smell. Maybe bad.
Yes.
Yes. Third one is the odor. Then we have the density. Fourth one is the density. What is density? It is the space
The hardness.
occupied. No, not. Yes, we can say, but it is the space occupied by the particle. If particle are occupied the
Yes,
less
sir, that
space,
includes the
yes,
hardness
so
of it,
density
sir.
will be yes. Okay,
Sir,
then
so
we have
like
the
the
texture.
physical nature of matter is like independent of the amount of matter present.
Yes, most of the properties, they do depend on the matter, but sometimes, suppose in a container we have taken the gas. Suppose here we have the closed container like cylinder. Okay, and here we have taken the 1 liter of gas. So 1 liter of gas will acquire whole volume of that container, right? 1 liter of gas. Okay,
Yes, sir.
if we will take 5 liter of gas, so 5 liter will also acquire the same volume, but here particle will present very close to each other, so we can say density of that substance increases here. So whatever the particles we have, if they are very closely arranged, so density will be high. If they are like away from each other, so density will be the low, like this. Okay, then we
Yes, sir.
have
So like it's
melting
independent.
point. Yes. Melting point, boiling point, and solubility. So all these are nothing but there's those properties, they are depends on the observation or the measurement. Okay, is nothing but they are the physical properties of the matter. Okay, so just do remember, first one the appearance, second is color, then we have odor, fourth one is density, fifth one is texture, sixth one is melting point, seventh one is boiling point, eighth one is solubility. Okay, so all these are nothing but the physical properties of matter. Okay, now we are going to understand the characteristics of the particles of matter. Very important. Okay, so what is matter? It is nothing but anything that has mass and occupies space is called as matter. We already gone through that before. Okay, and everything that we can touch, okay, whatever we have in our surrounding, okay, and if we can touch, we can see, we can hear, we can taste, and also we can smell. Okay, so whatever the matter we have, we can perform all these activities to them. Okay, so everything that we can touch, see, hear, taste, also the smell is nothing but the matter, is nothing but the matter. And sometimes we can sense also the air. Okay, the air, it is, you know, always or continuously flowing, it is nothing but the fluid, so we cannot see that, but we can sense that. Okay, so it is also matter. So it is made up of really a tiny particle. So whatever the matter we have in our surrounding, they are made up of very tiny, and according to the, you know, definition by that Rishi Kanad, okay, they are indivisible particles also. They are very tiny, kind of microscopic and indivisible particles, which cannot be seen throughout the eyes. So by normal eyes, we cannot observe them. But Tyndall effect, you know, Tyndall effect, in Tyndall effect, we can observe those particles easily. You know what is Tyndall effect? Suppose here we
Yes,
have
sir,
one
like in
dark room.
colloids.
Yes, yes, yes. Suppose here we have the dark room, and here we have the gaseous particle. Everywhere we have gaseous particle, and when a light rays, when enters in this light from the small beam, okay, so when light enters in the room through that small beam, or in that beam of light, we can sense or we can see the particles, they are randomly moving in all possible directions.
So like they are
Yes,
like
sir.
in the
Yes,
scattering of light.
yes, it is due to the scattering of light. It is due to the scattering of light, okay, that particles can be
And
visible.
not
So
only in the beam of light, sir. Like when
yes,
it can also happen a huge amount of light also, sir.
yes, and sometimes it happens, you know, the canopy of the forest also, when we used to visit the
Yes,
dense
sir,
forest.
like
Yes,
canopy of dense forest we
yes,
may
yes,
have
yes,
some.
there also we can observe the particles. Okay, so only there, otherwise in normal air we cannot observe the particles. In a room outside our house we cannot observe the particles. Okay, means they are very tiny. Okay, the particles of which the matter is comprises influence its state and properties. Okay, so whatever the tiny particles we have, okay, like different, we can say different matter, they are made up of different type of tiny particles. Okay, and on the basis of properties of that tiny particles, properties like physical and chemical properties is decided by the particles only. Suppose we are taking example of the fiber chair. So the fiber chair is made up of the small tiny polymer atoms and compounds called polymer, and those polymer, they combines together to form the matter, and that matter can be molded into different particles or different matter. Okay, different kind, like suppose we have that yeah, we have notebook, so it is made up of different type of particle. We have the wall of our house, again it is made up of different type of particles. We have grills on our home, they are again made up of the iron particles. So whatever the different kind of matter we have, their properties is decided by what type of tiny particles they are made up of. Okay, means the properties of the matter is decided by the type of tiny particles they are made up of. Is it everyone? That's why plastic have different property, the papers have different property. Like property means what? Their appearance is different, melting point, like boiling point is different. All these are nothing but their appearance is will be the different. Okay, understood everyone?
Yes,
Yes,
sir.
sir.
Okay, so particles of matter have space between them. First we have here number one, and which is the particle, whatever the matter we have, their particles, they are closely arranged with each other, and they have suppose here we have one molecule, and here we have another molecule. So these particles have intermolecular force of attraction between them. Which force?
So like
Intermolecular.
positive and negative like attraction.
That may be different, beta. It is only in ionic compound. Okay. Like
So
suppose if we are discussing about water molecules. Okay. So in water molecules, one water molecule is bonded with other water molecule, right? So here in this two different water molecule, here we have intermolecular force of attraction. Force of attraction.
so like they have been chemically bounded like a compound.
Yes, not compound, beta. Compound, suppose if we are discussing about H2O only, so here we have hydrogen, oxygen and hydrogen bond. But between one water molecule to other water molecule, suppose ice present in like ice form. So ice cannot be break easily, right? If you will heat that, then it is going to melt. Is it?
Yes, sir.
So where one water molecule is strongly bonded with other water molecule. So what is the force acting between them? So it is the intermolecular force of attraction. Okay. So if intermolecular force of attraction very high, particle will present very close to each other, but still
Or
they
like
have.
take more amount of heat to like break them apart.
Yes. Suppose if we are discussing about sodium chloride, the ionic compound, so it is made up of the salt we are having every day in our diet. I am discussing about that, sodium chloride. So we know sodium positive ion and chlorine negative ion, they have force of attraction, and it is called as electrostatic force of attraction, because the force of attraction working between two different charge particles. Here we have positive charge and here we have negative charge. So they are opposite charge particles, hence they attract each other. So opposite charge particles, they attract each other by the force. That force is called as electrostatic force of attraction. Okay, so they are highly negative and positive charge, so they are very closely bonded with each other, but still they have the space between them. Okay, still they have the space between them. We are discussing about that here only. Okay, so and that intermolecular space is depends on the intermolecular force of attraction. A force of attraction, so I'm just giving you one formula here. Intermolecular space is inversely proportional to the force of attraction. Fa means force of attraction. If force of attraction is more, the space will be less. If force of attraction is less, then space will be more. Understood, everyone?
So I can explain the sodium thing.
Okay. So let me move the screen aside. Okay. So suppose here we have beta sodium. Okay, and we know sodium present in solid state, and chlorine. And we are reacting that sodium with chlorine gas, and chlorine is present in gaseous form, and when they react they form NaCl, and which is the sodium chloride, and which is crystalline solid, and we are having every day that sodium chloride in our daily diet. Is it, everyone?
Yes, sir.
Yes. So yes, sir. That sodium is going to react with chlorine in this state? No, they are not going to react like this. If we will have like sodium piece and you will enclose that sodium piece with chlorine gas, so next day you won't get sodium chloride. The reaction does not follow like this. It is only the representation of reaction. So how reaction takes place? So first we had to convert that sodium solid form into the gaseous form. So first we are going to heat that sodium, then it will convert into gaseous form. Okay, so this process is called as beta sublimation. Yes, so first we had to sublime the sodium from solid to gaseous state. And here we have chlorine, it is in molecular form, so we have to convert into the atomic form. This process is called as atomization.
Yes, sir.
Atomization.
Sir, can you again tell what's atomization?
The forming or the breaking down of molecules into the atomic form is called as atomization. Okay.
Okay, sir.
So here we have suppose chlorine gas, and if we will atomize that, so we will get two chlorine atom. So from molecule it converts into the atom. So it is called as atomization process. Okay, next. Now that sodium, again we are going to heat that. So sodium will lose one electron. So sodium will lose one electron and will form positive ion. How? By loss of one electron. So that sodium positive ion again will present in gaseous form. Okay, and from atom to ion, okay, that by loss of electrons, sodium gaseous atom converts into sodium gaseous ion. Okay, that's why this process is called as ionization. Ionization is the
Yes.
process in which atom converts into ionic form by loss of electron. Okay, now that electron, chlorine will going to add, chlorine will going to accept, because chlorine is non-metal. And why it is non-metal?
Sir,
Because it is going to accept electron.
yes,
Huh?
sir.
Yes,
Valency, sir.
yes. So chlorine is going to accept that electron and will form sodium, chlorine negative ion. Chlorine negative ion at gaseous state. Okay, so now here we have chlorine negative ion. See, they are here we have sodium positive ion in gaseous form and chlorine negative ion in gaseous form. See, if they are in gaseous form, so probably or not probably, definitely they are going to attract with each other, because we know opposite, yes, opposite charges attracts each other and same charges repel each other, right? So here we have sodium positive and chlorine negative ion, so they will going to combine and will form sodium chloride. Okay, this is nothing but the way how sodium chloride is formed. It is explained by the Born-Haber. That's why it is also called as Born-Haber cycle. Okay, it is called as Born-Haber cycle. Now understood?
Sir,
Yes.
like if you can once again explain it, sir, with a proper, proper drawing, sir. I got confused, sir, at last when I see the whole picture.
Okay, I am just going to make you understand that sodium positive ion and chlorine negative ion, they are oppositely charged particles. So they will attract each other and will form compound. So here force of attraction will be higher. I'm just going to explain that. Sodium and chlorine, they are opposite charged particles. That's why they have strong force of attraction. And that force of attraction between positive and negative charged particles is called as electrostatic force of attraction. Okay,
Yes.
electrostatic force. Yes. So it is very strong force. Okay, is it very strong force? If force is strong, then particle will present very close to each other, right? But still they have the gap between them. That we are going to discuss, not that formation of sodium chloride. I will just explain how the process takes place. Okay, beta?
Yes, sir.
If you want to repeat, I will upload that video today itself. You can go through that also. Okay. Okay, so first point we are discussing here, particles of matter have space between them. So this is the characteristics property of the matter, one of the concept behind the solubility of the substance in other substance. Okay, see what happens generally when we are going to mix one substance to other. So one matter like dissolve in other matter, we can say. Suppose if you are going to have that salt, and that salt you are going to dissolve in water, so it will dissolve completely, right? Means one matter, suppose I'm just going to make you understand. suppose beta here we have a glass container, and here till here you have water. Till here you have water. Understood?
Yes, sir.
And suppose you are going to dissolve 2 teaspoons of salt. 2 teaspoons of salt. So when we will dissolve that salt, that level will remain same here. See, you are adding salt here 2 teaspoons, but still the volume is not going to change, will remain same only. That means when you are going to dissolve 2 teaspoons of salt in water and volume is not increasing, that means water molecules have space between them, and that space is get fulfilled by salt. Can we say that?
Yes, sir. It also shows the fact that the two teaspoon of the salt is like not settled down, so that
Yes.
will like increase the height of it, level of it.
Yeah,
Sir,
because
but when it is like saturated, then it's like
yes,
increase.
if water, that solution is being saturated, and if you will add more salt, then level will going to increase. Okay, but if solution is unsaturated, then level of that solution is not going to increase. It shows that water molecules have space between them. Understood?
Yes,
Yes.
sir.
Yes, sir. So that we are discussing here. This is the point. Okay, very good. For example, dissolving sugar, we have taken here salt. In example, we have the sugar in water. There is no rise in water level because the particles of sugar get into the interparticle space between the water. That means whatever the water molecules they have space, sugar particle will get space in between them. Okay, that's why that volume of the water or solution is not going to rise till the solution becomes saturated. Understood, everyone?
Yes, sir.
Yes, very good. Next, particles of matter are always in motion. Okay, this
Yes,
is
sir. They're
again
like
very
always in motion due to like kinetic energy.
yes. Okay, so particles of matter shows continuous and random movement due to their kinetic energy they possess. Okay, suppose you will say, suppose I'm just taking example of water. Okay, suppose here we have again one container, the glass container, so that we can see how particles they are moving. Wait a second, I'm just taking, someone is in meeting room. I'm just taking in. Okay. Okay, so in liquid, suppose here we have, till here we have water, and suppose if you are going to add any like color, the stainer, suppose you have taken blue stain. Okay, so that blue stain will dissolve here and will distributed uniformly throughout the solution after some time. Is it? It shows that particles of that particular matter, they are randomly moving in all possible directions. Okay, even in solid state. Okay, so suppose most of the time student says, sir, particles of solid are also in motion condition. So yes, they are also in motion condition, but they used to move with the mean position. That means suppose one particle is here, so it is going to move like fro and back again. Okay, fro and back. Okay, fro and through like this. Here
To and fro.
like this. Yes. Okay, in all the possible direction, because all the particles, they have kinetic energy in them, and due to that kinetic, and why they are moving, because they have interparticular space between them. We discussed in first point. So they have interparticular space between them, and in those space these particles of solid are also performing motion. Okay.
Yes, sir.
Yes, now next point, the
Sir,
rising.
like when the temperature increase, they move very
Yes,
vigorously. They
yes.
change the
Then
state.
yes, and that motion of the particle is increase in temperature, because when particles will going to absorb energy from the surrounding. Okay, suppose you are heating any matter, so matter particle, what will they do? they will absorb energy. Oh, energy is coming. Oh, let me have more energy. So their energy level will going to increase. And once their
But if like
energy,
temperature increase, like they'll have an increase in energy and they will
yes, yes. So due to higher, so they have always tendency to switch from lower energy to higher energy level. This is the tendency of all the matter and particles. Okay. So due
so they
to
also collide with the
energy,
particles and share energy.
yes, yes, yes. Okay. So when energy level will increase, so they see due to increase in energy level, they perform random and fast motion with their respective position only. Okay, the mean position. So second point, it has been explained here. To rise in temperature, increase the kinetic energy, because particle of the matter will going to absorb energy, and due to increase in energy, they will perform more motion. Okay, more motion in respect to the rapidly, okay, of the particles, making them move more vigorously, means more randomly, like very fast, like this. Okay, everyone.
So like if like that's why we have, when you heat liquid, then it
Yes.
changes to gas and the particles move more vigorously.
Yes, yes, yes. Okay. So any doubt here in second point?
No.
Okay.
No, sir.
Okay. Now next, third particle. Particles of matter attracts each other. Yes, we know that, because we have different kinds of force of attraction which is working between different type of matter, different kind of particle. Okay, like we discussed here about the water. So water have one water molecule attracts other water molecule. We discussed about the sodium chloride. Here the force of attraction is due to the opposite charge particles. We have London force, we have dispersion force, we have different kinds of force by which one particle is attached with other particle and one particle attracts other particle, and it is the universal truth. What?
Yes, so like the ability to attract is like more in solids.
Yes. So universal law of gravitation, I'm just going to explain you. Okay. The universal gravitational law states that every matter of the universe attracts other object of the universe by the force. And that force is directly depends on the product of their masses and inversely depend or related to the square of distance between them. So according to that statement given by Newton, we can say that all the particles, if they have mass, will attract each other. Understood, everyone?
Yes, sir.
Okay.
Yes.
So let's discuss from the notes. In every substance, there is a interparticular force. It is also called as intermolecular force of attraction or interparticular force of attraction working between the particles. Okay, it is between the particles, so we can say interparticular force of attraction. If it is between molecules, so it is called as intermolecular force of attraction. If it is between ions, so it is called as electrostatic force of attraction. If okay.
So like they all attract due to gravity?
Yes. No, not due to gravity. It is due to the, they present with very closely to each other. All the particles, they attract due to gravity. All the particles. Okay. So we are not discussing here about I have given only the example that all the matters of universe. See, we are on the earth, but still we have force of attraction of moon, force of attraction of sun, and whatever the planet we have. Okay, means other celestial body also we have out of our uh, solar system, they have also force of attraction between us, but we are on the earth, so we have very close, like distance between earth and us is very close. Only the radius of the earth, whatever the distance we have between the center of earth and us will be the radius of earth. Is it or not? So we are very close to earth, we are on the earth, that's why force of attraction with earth is very strong. That's why we are not moving toward the moon, toward the sun, or toward the other planet. Okay. Here we are discussing between the matter, the particles of matter. Okay, Lalita Ditya.
Yes, sir.
Okay. Okay, so we are discussing here the force of attraction between the particles of matter. So it is not due to the gravity, it is due to the properties of matter only. Okay, to break the substance, we need to overcome this force. Suppose here we have the ice cube. Okay, and if you want to break that ice cube into two parts, so you have to apply the force. Why? Because here the force of attraction we have between water molecule, we have to break that force of attraction. Then that particle or the piece of ice is going to break down into the two pieces. Okay, so that required force we had to apply in order to break the particles or matter into two or more pieces. The strength of the force differs from substance to substance, means you will be easily going to break or the tear that page of your notebook, is it? But if I'll give you the same, width and length and the diameter, whatever the dimension of that page, if I will give you the metal sheet, so you won't be able to break that or tear that, right? So it depends on matter to matter, because in different matter the force of attraction is different. If force of attraction is very strong, so more force will going to require in order to break that force of attraction. That's why different matter have different melting point and a different boiling point. Understood, everyone? Understood, everyone?
Yes, sir.
Yeah.
Okay.
Yes, sir.